well, one thing about statistical downscaling practice is that traditionally we've focused on temperature and precipitation, two scalar fields. And of course, there's a lot more to climate than TMP. If you're an ecologist interested in evaporation, or many sectors need to know about wind and so forth. This brings in the need for dynamical calculations, as well as, I think, statistical techniques that can extend the reach of dynamical calculations, and we are working on those kinds of technologies, I would say, collectively in this gathering.
Okay, thanks to the community. Okay, we'll start with your first question.
Hi, is this on?
Yep.
My name is Jason Funk. I'm here from the Union of Concerned Scientists. We're a nonprofit group that advocates for better use of science and policy making. I'm actually visiting here from Chicago because sort of what we heard at this morning's plenary about California sort of being a beacon for other places, I think is very much true. What I've heard at this session is a lot about the information that's being brought to bear on the climate change issue in California. And we've heard a lot about uncertainty and sort of the quantity of data that's available and how it's being manipulated. But I'm sort of wondering about what's been the payoff. What's the payoff for California that you guys see from all the investment in this science? How's it coming together? How can it be utilized? If I were going to go back to another state and say, you know, look at what California's done and here's where it's leading. Here's the value of this investment. Can you all say a little bit more about that, please?
Yeah, so we'll start. I think the payoff has been huge. Just starting with the fact that we have AB 32. I mean, that law was passed in part because of the work that was done downscaling, you know, global climate models to estimate the potential impacts of climate to California. In addition, it has also been used, the climate scenarios, they have been used for long-term planning. For example, the Department of Water Resources have used some of the prior scenarios in their 5-year water plans. The Department of Cal Fire, you know, they have the 5-year, the same thing plans. And for the first time, I realized that somebody plans for the next 100 years. Because plants stay, I mean, trees stay there for a long, long time. So I'm glad to actually find the group that was actually using the entire range of the scenarios for planning. Department of Fish and Wildlife also, I didn't have to use these scenarios. The Integrated Energy Policy Report, that's a report that the Energy Commission has to provide to the governor and the legislature every 2 years. It's a major energy planning document. For California, we started to use that like 3 cycles ago, again, to estimate how climate change will impact the energy system. And the good news is that we now know that something that we need to adapt, and steps that are being taken to eliminate or avoid or reduce, you know, the possibility of blackouts and other major disturbances.
Okay, we'll take a question on this side.
Yeah. Thanks a lot. It's a great session, and I'm really encouraged and impressed to see, you know, the big steps forward that are going on, particularly focusing on physical processes, understanding probability and extremes, and also sorting out different sources of uncertainty. And the question I want to ask is about the third of those, about uncertainty, in particular the issue of internal variability that came up a number of times. And you know, there's been so much consternation, particularly in the practitioner communities, about model disagreement. But in the scientific literature, as Alex mentioned, over the last 5 to 10 years, we've seen really that a lot of the model disagreement has not been model disagreement, it's been internal variability. It just has different model labels on one realization, so it gets called model disagreement. We've seen in IPCC working with 2 for this screening for statistical significance as the primary screening, which really affects the precipitation model agreement. We've seen these really large ensembles, 30 realizations of a single CMS GTM. So the question is for this, for California's next assessment, what are your thoughts about integrating that scientific advancement in understanding the role of irreducible uncertainty, and what are your insights about communicating that so that we don't continue to get hung up on models disagreeing about the direction of precipitation change when really they mostly agree on there not being statistically significant change in annual precipitation in California?
Well, I think, yeah, we've been grappling with this a lot. And the way that we have done it so far is just by trying to show how much variability there actually is and comparing that to the signals so that we can communicate how large the expected changes are compared to what people are already adapted to. And the variability in California being so huge, actually we are adapted to quite a bit of change from year to year. So I think it's especially important here. But I think you're raising a really important communication problem. And I think all we can do is give a sense of the magnitudes of variability compared to signals.
So Noah, I think so. You're doing some of this, and case in point is the drought, which happens to be not only persistently dry, but also in the last 2 years extraordinarily warm. And so I think that we can use observed variation as well as possible change as a learning device. That I think nothing appeals or kind of convinces decision makers more than something they've already seen some of. And I think we have to not only look at the projection complete with all its variability, but we also have to remind ourselves and them of the sorts of variation they've already seen in order to prepare and going forward. And we do live, in terms of precipitation, California is the most variable. The most variable region in the United States, and we scale it by the average. So that's really part of the story, and it's something that we don't want to just average the heck out of all the simulations and say there's the signal when we know that there's going to be this natural variability. So I think that's part of the message, and I think we have to sort of embrace that.
I will only add the historical records to show, again, that we need to look at the paleo record. For example, work done by Mark Snyder, I believe, from UC Santa Cruz and Lisa Sloan, suggesting eons ago that there was a potential link between warming of the North Pole and drought conditions in California. And now there are some evidence by Isabel Montañez from UC Davis that she's finding out actually that seems to be a reality. So
Gentleman in the side, please.
Hi, my name is Phil King. I'm an economist, so I feel a little bit out of place here. But I'm trying to I model climate change. I'm trying to understand precipitation. So this is a somewhat similar question. My broad take from Dr. Kahan's talk and the other talks there was, if we look at the average precipitation going out in the future, it'll be a little bit drier in Southern California, about the same in around Sacramento, maybe slightly higher in Northern California. Is that completely wrong, that takeaway? And how much uncertainty do we have? It seems that we have at least some reason, although there's variability, it seems that the model seems to indicate that those projections are fairly consistent.
Yeah, not bad. If you look at the global sort of distribution of precipitation change, one thing that's quite striking is the fact that the subtropical high regions tend to be getting a bit drier, and Mediterranean regions globally are drying. Our Mediterranean region, for whatever reason, and I'm not sure we totally understand this, Mike Dettinger in the back has participated in this study, but it's not becoming as percentage-wise drier as, say, the European Mediterranean region when we look into climate simulations. But there is a general systematic tendency for drying. By the time you get to Central California, that tends to be kind of washed out, and by the time you get into the Pacific Northwest, the fulcrum is kind of on the other side of the coin. But the variability, I think, is probably the key message that, you know, we continue to get this very strong variation. The other thing that you didn't mention, but I think is lurking in the climate simulations, is that the distribution of precipitation is changing. And Alex gives an interesting talk where he shows that on average, the number of dry years in parts of California increase over historical numbers, but occasionally you get a very wet year that counteracts the tendency for drying. You also see that same kind of thing when you look at the daily level of granularity. So more dry days, but occasionally at the tail of the distribution, extremely more precipitation, which probably has something to do with the atmosphere getting moisture.
Well, Alan should make this point, but you know, there's also the profound influence of warming on hydrology, and we're seeing this abundantly clear in the recent drought. You know, where water resources are actually probably less than they would be if we didn't have this warming signal. So the in some ways, this is a very interesting laboratory for climate change because the precipitation signals are rather weak overall, but we do still have warming, and so you can, and that really does impact hydrology. So, and that does, and it's in a long way, it reduces the resource, I think. So that's, and I think that's actually going back to important data that we got to produce. I think that's a really very profound question about this region's climate: is how will this warming impact the hydrologic system?
And from a water resources perspective, I'll speak on behalf of EWR for California. What we're concerned about is the projections did indicate with the warming, even if the precipitation is the same, put it into English, if we have less snow, even if the total precip is the same, that will cause us management problems.
Yeah, I just commented that this warming is an important trend. And in the modeling work that we do, because we have a Mediterranean climate, what we find is that in the wet years, that extra water is goes to recharge the runoff. And we still start off in the spring with the same amount of water in the soil that we do on almost every year, but because it's drier, hotter, we put more stress on the landscape. That's why climatic water deficit goes up in all cases, because even wet years, the water is gone by March and April. So that becomes a very significant thing in hydrology.
We better move on. Try to get a couple more in. Go ahead.
Hi. I'm actually looking, I came here with the intent on finding a more practical, down-to-earth plan that could really work within communities who are actually feeling the effects of all of the climate change and the water drought now. And so I guess I'd like to know how all of this data that you guys have put together, how do I get my young folks that I train on sea level rise and a little bit on the climate change and things, we're looking for practical applications that they could be doing now, not in the future, and a whole bunch of folks are still under the assumption that we have years before all of this starts to impact us, when the reality is that we don't. It's happening now. My job is to train these young folks in how to use your information, your data, really practically. They're very visual, keep that in mind. How to utilize it now, how to train their parents and their children coming behind them. This is what we need to start doing now. In the valley, they're already experiencing a lack of water. They're now considering paying farmers not just to grow certain crops, but not to grow anything, period. This is not a good idea in our view. When you talk to a very young person and they talk about sustainability, this sends up a great alarm for them. So I'm hoping that you guys can help me with that.
Thank you.
Sure, I'd be happy to talk a little bit about that. I don't know if you've looked at CalAdapt as the website before. It's a really great tool for teaching people about climate change science. The visualizations are really easy to play around with. It's easy to look at different parts of the state and different climate modeling projections and futures. So I think it's a great resource for getting young people to start thinking about those issues and talking about them. So I think that would be a great place to start. We also include a lot of different resources on adaptation planning on the website, which would also be a really good place to start to look. There's a lot of work that has already been done in the state on adaptation plans, so there's a lot of resources and stories for people to look at that might help to inform that. And I'd be happy if you want to look at our website a little bit later. I'd be happy to go over with some of it with you and see if we could come up with something for your students. Right. It works for them too. Yeah, the visualization tools are really easy to use and can be very informative. So I think it's a good starting point for a discussion.
And it is underway. Okay, one more question, last one.
Hi, I'm a reporter from the Central Coast area with, I hope, a relatively simple question about the scale of impacts of climate change in California versus the globe. I think I heard from a previous IPCC report that California was kind of one of the most expected to be impacted areas, if that makes sense.
Well, I think it depends on what your flavor is for your popsicle. So, you know, we have...
Very good point, Dan.
We can go to lunch now.
So we obviously have water issues, and we just heard about hydrology. We have coastal issues. We have the largest estuary along the West Coast, where we have the confluence of water from the freshwater system and the ocean. So there's things that come to a head. You'll hear talks, at least one talk tomorrow about that, actually more than one, I think. We have various resources and health issues by way of wildfire, air quality, which gets exacerbated as we get warmer temperatures. We're an agricultural state. We are a semi-arid state. So all of these boundaries that exist, whether we're talking about boundaries between coast and interior, or we're talking about boundaries between low-lying and higher elevations, those gradients are going to incur extraordinary amounts of change because the natural climate changes so rapidly. So there are a lot of examples, but I think every region in turn has their own sensitivities, and that's one reason why we have to look at climate from a regional perspective and not simply look at global broad brush or be beholden to a central federal agency. I think the example of California looking at its own setting is one of the examples that we can point to about how we're learning about, you know, our vulnerabilities here. So, you know, I could go on and on, but
I just quickly, I think that the one reason why California seems so vulnerable is because we've been studying California, and we've had a lot of really talented people looking at California. It's an incredibly resource-rich state, and so we know a lot about climate change here. I think if you go to another region, you'd find that impacts are also significant, and that's why it's so important for us to get this right here in California, because if we can perfect the model of knowledge creation on climate impacts here, then it's a model that we can apply to other other regions of the world that are perhaps less wealthy than California. So I think the impacts are significant everywhere. We just don't know what they are.
Just one, I guess, final thought on that is, if we look at something like potential evapotranspiration, it's non-linearly related to air temperature. So a 3-degree rise in the middle of the Mojave Desert is not going to have the impact a 3-degree rise on the North California coast will. So it's a matter of scale and where you are in the state, as Dan said. We have this huge range. And so the same temperature rise is going to have a major impact on parts of the state and not as much on the other.
Well, thank you. And as you adjourn to lunch, maybe one more thank you to our whole panel.